Hello and welcome to another IC Monitor tutorial. In today's tutorial, we'll learn how to export specific node or telegram data using the capture export options. We'll introduce the capture export and how it relates to the other capture steps. We'll configure the IC Monitor to export node data to files and learn how to combine that with the use of filters and triggers. We'll introduce the API concepts and most important functions, and of course use the API with an example script. Captured telegrams go through a capture buffer, or in case of file capture, go directly to protocol processing, where protocols and their individual nodes are identified and processed. Capture triggers and filter are then applied, and depending on your configuration, capture files are stored to PCAP or PCAPNG files. There are tutorials on all those capture functions, so feel free to browse the channel for them. Now, in the last step of the capture settings, the capture export is applied. This function allows the users to extract specific telegram data during the capture process. Users can configure so-called export handlers that contain a selection of data network nodes or whole telegrams. Data from the selected nodes is then stored in pre-configured files like CSV or TXT and can be used for future analysis. It is also possible to configure capture export handlers that will then trigger API callback calls. So you can use your own scripts or C# programs to handle the telegram data. Basically, capture export allows the user to extract the data they need for their use case for further analysis outside of the IC Monitor. By default, this option is not active, meaning only when user configures capture exporters, this step will be processed. The capture export configuration we'll discuss in this video can be found in the Capture tab, in the Capture Settings group, in this Export dialog. Various export handlers can be configured by the user, each with an individual data composition to be exported. A basic distinction is made between file-based and API-based export handlers. The user can also choose whether they want to export a specific selection of network data nodes or the data of entire telegrams. Let's take a look at the dialog and go through the various options together. Let's start by configuring a general file export. For this, we go to the list of active export handlers, pick the type we want to configure. In our case, we want a general file export for node data, and then just add the handler and configure it. We'll start with giving a file name, and picking the format we want to have exported. I'll pick the classic CSV separated by semicolons. Now we can configure the network nodes that we actually want to record in the file with a network node configuration dialog. To make this easy to demonstrate, we'll go with the classic ICMP. We'll pick type and code and add some fields from the IP header as well. Time to live might be interesting, a source and destination. Now here we can also influence the different formats that we want to have. For ICMP type and code, we'll leave it bit encoded and an ICMP type. TTL, of course, is just a number, so we'll leave it an unsigned decimal. And for the IP, we'll leave 1 in decimal and maybe change 1 to hexadecimal for demonstration. If we're happy with our configuration, we can apply it, and we're now ready to record to a file. We'll apply the settings, pick our capture interface. In my case, the choice is very limited, and we'll start the live capture. We'll be informed we have active capture settings, which in our case are the export handlers, and we're now recording. Let's insert some traffic that we can see by performing a trace route to Google's DNS server. So now we have a couple of ICMP packets. Let's stop the capture and look at our file. As we can see, we have the columns up here and their headers, and underneath it we have the data we recorded. But as we're interested in ICMP, it seems very difficult to find the proper telegrams. You can still do it by scrolling through, but it's a little cumbersome. So let's maybe just adjust our export a little bit and give it a capture filter. We only want to see ICMP telegrams, So let's filter for those, apply the settings, restart the capture, and perform the trace route again. Now we can see in our list view, we only have ICMP telegrams, so that's what we'll expect in our file. We'll stop the capture and take a look. And indeed, we only have the ICMP telegrams as expected. We have the type, we have the ICMP code, in this case our enum, the TTL field, and the IP addresses. We could also import this in Excel, and Excel can maybe format the data a little bit more clearly for us. If you want to identify a pattern on the network, this might not be specific enough yet. So let's go back to the export and see what else we can do. Now, if you want to observe traffic for a longer time, it makes a lot of sense to export multiple files. And we could also export a file for each trigger activation. So let's try out that. We'll set these two options, then go over to the trigger conditions, pick a start and stop. I'll make this simple. I'll start on the first ICMP and stop on any non-ICMP packet. We'll have the trigger activate continuously, so we can generate multiple files. Apply the settings, start our capture, and let's see what we can catch. In this case, it makes more sense to just ping a simple machine. So we can get each ping and reply in a separate file. And indeed, this here is our earlier trace, and here we have one file for each ping. Let's look into one, and as expected, we have a request, a reply, and the involved IP addresses, TTL, and so forth. Now, if our data is not defined that clearly, or we just want to capture all network data in a different format, we can also capture the whole telegram data in a file. For this, we'll remove the current configuration, add a telegram data handler. We'll leave the filter in place, as to not overwhelm us with data. Here we can't configure any nodes, and we only have the .txt format available. We can, however, pick a name, remove our triggers, apply, and let's see what we catch. Start the capture again, and ping a machine on the network. Now the ping has gone through. And if we look in our newly generated test telegram file, we'll see it'll hold the complete telegram in hexadecimal format. Now let's reset our settings and discard what we caught and take a look at the API. So as previously mentioned, the IC monitor can be used via an API, either for regular operation or, like we'll do in the following example, for processing node or telegram data in your own applications. Your application must reference the data model DLL and the core API DLL from the IC monitor's installation directory. Since we are using Python's PythonNet module, we can just access the files as they are. IC Monitor does provide a way to use the API from unmanaged code like C, but that's a topic for a separate API tutorial. We will now use the iMonitor Core API interface to perform a basic setup and start operation. For more information about the Core API, the API documentation, available via the IC Monitor's website, is a good start. If you're a license owner, you can just go to Downloads, go to Downloads for license owners, and under Documentation, you will find the Monitor Core API specification. If you download it, you get a zip file that contains some API examples for various programming languages, a header for your C applications, a document that we'll take a brief look into. So here we are with the IC Monitor API documentation. It'll give you some hints on how to get started, and mostly show you how the IC monitor works internally on a very abstract level, so you know what the functions will do and how to use them properly. There are also some examples and a detailed explanations of the monitor settings. So use this document as a start for working with the API. If you need an overview of the API, there's a CHM file where under Core API, iMonitor Core API Interface, you will find a list of all the functions that are available to you and a short documentation. In combination with the Monitor Core API documentation, you should be able to get started using the API without any issues. To use the API with export handlers, they must first be configured in the IC monitor. Of course, the configuration can also be imported via the API if you don't want to use the latest XML. That is used by default if you don't specifically load a configuration. That might be convenient if you just have a single installation, where you can just configure your IC monitor, load up the API, and don't have to worry about loading various configurations. Depending on your export handler configuration, you can then register a callback function, and the IC Monitor Core API will provide functions to do that for the various types of handlers. The callbacks will then be executed by the API when data is available, and you will get an index to relate the data to your current configured handler. Configured export handlers are numbered 0 to n, depending on the order they were created. Using this index will help you make sense of the data you receive. So now that we have a basic understanding of the API and how it works with export handlers, let's test it with a little Python script. I went ahead and configured a couple of export handlers. One will give us node data as byte lists. It'll pick the ICMP type out of ICMP telegrams and TTL, destination, and source from the IP header. We'll also export the source IP address and destination as strings, just to see a different callback function used. Once you configured this, we'll go to File, Export. If we don't want any other settings, we'll just pick the capture settings we just configured, select the file, and export it. Now we have a configuration that is ready to use. So let's take a look at our script. On top we find a reminder that we have to install python-net for this to work, and you can just copy the imports and the import of various classes from the example that is provided with the Core API documentation. We need to tell the API where its files are, and for it to be able to recognize which version of monitor you're running, we also need a path to the executable. We'll then add references to the Core API and the data model DLLs, and we're good to go. Now, as I said, we need to set the program directory so the IC monitor knows where to look for DLLs. We'll then need an instance of the Core API, which we have here. We'll have to initialize and start and import our settings that we just exported a minute ago. Now here's some code that makes it a little more convenient to select interfaces, but if you know your interface ID or can identify it with a string, you can basically skip all this and just select the capture device by ID. And now we're ready to set up callback functions. We have two handlers, so we have two callback functions. One is a byte list and one handles strings. There are dedicated register functions for these types of callbacks. And you only register one callback and identify your exporters by index. So if we look into our string callback, it basically just prints out the data string for IP source and the data string for IP destination. If we look into our byte list callback, we of course need to interpret the bytes that we get. So we'll print a bit of inventory for debugging and then interpret our data. We'll get a list of byte lists, so be aware that you have a two-dimensional array to work with. Now the first one contains our ICMP type, so we'll just extract that and simulate a little enum. With the second one, we'll have the TTL field. You can just use it as is, because it's just a number. And we'll use Python's IPv4 address module to translate the unsigned integer IP address with destination and source. And finally, we print it all out so we can verify if that is done correctly. After registering, we start a live capture and stay in that state until somebody presses the enter key. After that, we'll stop capture, wait for it to properly stop, and save what we captured to a pcap.ng. And that's basically the script, a slightly modified version of our demonstration script. So let's see that in action. So here we're in the folder with the script. We have our configuration and the Python script right here. So we simply go ahead and run that Python script. It'll give us a lot of debugging information and information about loading up various parts of the IC monitor. In case something goes wrong, we have some information to work with. Now here we can select our active interface. For me, that's pretty easy. We only have one that is IPv4 enabled. So I'll select interface number 3. And now we're waiting for data. I'll ping a machine in my network. And here we see our callback functions are working. We have the string data node that just prints out the 2 addresses. And we have our byte list data node that prints out the ICMP type, the TTL field, and then concatenates all that into a string. So that's one example of how you can use the API to leverage a programming language to further interpret the data you're capturing. We'll end this process by pressing enter, and we now have our captured PCAP available for inspection. That concludes our capture export tutorial. Thank you for watching, and we'll see each other in the next tutorial.